It's a real honour to be here in front of you all. Actually quite intimidating because it takes me back to, when that was me, when I was your age, doing pure and applied maths at A-level, did all right. Went to university to do maths when I met Jeff, and I looked like that then. And then, to be honest, the pure maths got too difficult, so I took up statistics, and I ended up looking like that. So there's a warning, and then now I look like this, of course. So there's a warning to you all. And I must say, I've got an ulterior motive for presenting here, because, as I said, I changed from pure maths to probability and statistics about halfway through the second year in Oxford. And I'm really glad I did. So I'm kind of hoping to seed that into some of your minds that perhaps statistics could be faintly interesting in the future. So this is purely, I'm doing this purely to try to market the profession, not that it needs marketing. I should, actually, if you want to look, that's what I looked like in 1971. If you want a blow up of that, there I am, there, and you may be able to see a certain gentleman here in the front row, with rather, don't you recognise him? There's Jeff. With the hair, the one with the hair. That's Jeff. There he is. Exactly. Hasn't changed a bit. And then a year later, we looked like we'd sort of stopped being quite so serious and sober, and that's what we looked like then. There's Jeff. That was after our exams. So, and I've known Jeff for 50 years after that. So, yeah, it was a good time, but as I said, I moved on to probability and statistics and ended up sort of writing popular books, Art of Statistics, COVID by Numbers, and so on. And that's kind of given me some sort of public profile, because I was lucky enough, here's another bit of advice: make friends with a billionaire. No, they're really useful, because they give you lots of money. It's great. So 2007, I could change from a sort of pretty standard research job into a public engagement job. I was Winton Professor for the Public Understanding of Risk, with David Harding, hedge fund manager, paid for this and enabled me to make television programs, Climate Change by Numbers, BBC 4 documentaries, jumping out of a plane on a parachute jump. I became world champion at Loop with an elliptical table. This is a brilliant game. And you imagine, sorry, it's a slight diversion, but you would appreciate that. An elliptical table with a hole at one focus and a black dot at the other focus. Now, the property of an ellipse is that if you draw a line through one focus, it'll bounce off and it'll reflect off the edge onto the other focus. That's the whole property of ellipse. So as a billiard table, it's brilliant, because if you want to pot a ball all in one focus, you only have to bash it in any direction over the other focus, over the black dot, and it bounces off and goes in the hole. So I won the World Championship because of knowing a little bit of math. So there, it can help you. It can help you. And that was me demonstrating how many pieces of toast you would have to eat to every day to have a remote chance of getting cancer from burnt toast. Anyway, so that was... and then finally, peak of my career, I got on desert island discs recently, and there's first statistician. So that's why you should do statistics. Maybe many of you couldn't care less about desert island discs, but for a certain generation, this is a lifetime's ambition, much more important than other things like knighthoods and stuff like that. Okay, so I'd like to talk about interpreting data, and there'll be a few little challenges on the way, I hope. But that's the first quote I've got, is from Nate Silver in his really good book, Signal and the Noise. And it's a whole book on sports betting and election forecasting and things like that, and using some quite cool methods. But he has this brilliant insight to say that the data does not speak it for itself. We imbue it with meaning. People have got this bizarre idea that if you have lots of data, big data, stupid phrase. Anyway, if you've got lots of data, it'll tell you, you apply some algorithm to it, some AI or something, and it'll give up its secrets. And this is all complete nonsense. I usually use a ruder word, but I won't, given your youth. It's complete nonsense. That judgment, knowledge of how the data is collected, knowledge of why you're here and getting this data in the first place is absolutely essential for interpretation. It is not an automatic process. So, for example, here's some data. This is from Tuesday, last Tuesday. So here's some data on the COVID epidemic, and I could give a whole lecture just on this data. So basically, Okay, that's the number of deaths registered each week in England and Wales, is the size of the column. The green are deaths which don't have COVID mentioned on the death certificate. The blue have got COVID mentioned on the death certificate. So you can see these peaks. This first peak in March, remember it, two and a half years ago now, March 2020, shot up with double the normal number of deaths. Because if you can see a black line there, that's the sort of average numbers of deaths you'd expect. So anything above that are excess deaths, anything below that is a deficit of deaths. So you can see there's enormous excess in the first wave, then the second wave comes in, and then, you know, the waves have got the death rates. Once the vaccine started working, the beginning of last year, then the deaths dropped very severely, even though the cases came up. But there's all sorts of patterns in that data, which you have to know how the data was collected. It's so bumpy because it's death registrations. If the office isn't open on a bank holiday, you can't register the death and it drops. So you've got these artifacts like that. And then you've got some other things. Look at the first wave. There's a whole lot of green above the black line. These are excess non-COVID deaths. Okay, why might there have been excess non-COVID deaths in the first wave? Any interpretation of that? Yes?
Due to the COVID pandemic, other illnesses weren't focused on as much.
Yeah, I mean, because of disruption to the health service, because of other illnesses, some of that, not too much. We'll come back to that later. There's another explanation. Yes. Look.
COVID deaths that were reported as COVID deaths.
Yes. Did you know that?
No.
Did you just guess it? Brilliant. Okay. Yes. You know they sent everyone home, old people home to care homes from hospitals without testing them. Huge numbers of COVID deaths in care homes. But they changed the rules for death registration that a doctor did not have to see. Oh, right, you want me to use that? Okay. The doctor did not have to see a patient in order to fill up their death certificate. They could do it over the phone. And so people were being, you know, and when actually older people die of COVID, they don't get the standard symptoms at all. So people were dying almost certainly of COVID and not being labelled as such. So these were COVID deaths. So COVID deaths have been undercounted right from the beginning. Then look at the second wave. We got a deficit of non-COVID deaths. Why in that winter would there be fewer non-COVID deaths than you'd expect? Yes? Exactly. One reason there's no flu. Absolutely. Normally 20,000 people might die in winter over flu. No flu. Any other reason? Yes. Oh, sorry, I don't think I... Well, they're getting old. Yeah, no, exactly. Other diseases, people weren't mixing, and so that reduced all respiratory infections. You get colds and everything like that. Yeah, anything?
Potentially, it's because people who would have died in the year had already died from COVID.
God, you people. This is a very clever audience, isn't it? They're really they're really sharp, aren't they? Really, goodness. Okay, yes, exactly. It's called some people who died there would have died the next winter and died earlier. It's known as mortality displacement is the sort of official term, but actually the name given to it, a fairly official name, it's on Wikipedia, is harvesting. Now, you soon learn that that is not the sort of term to use on the media. They do not appreciate that term, but it is an epidemiological term when people's deaths are brought forward. Okay, what's happening now? Now, there's been a long run for weeks, if not months, of excess non-COVID deaths. And that, to be honest, is still a bit of a mystery. All sorts of competing. What suggestions do you think people are making about why there are a lot of excess non-COVID deaths at the moment? Yes? Sorry, I didn't hear that. Well, you think, again, because of the registration? Yeah, but they do, I think not, because I think people tend to get tested now. So I think if they have COVID, because everyone gets tested going into hospital. Yeah, sorry, yeah. I couldn't hear. Really, the acoustics here is not very good.
Some people might have been fragilized from the first and second wave, so they may have other conditions,
Yep.
which means that they're dying now because for some other reason like cancer,
Yep. Yeah. Exactly. There's a huge disruption of the healthcare. Been 30% extra people dying at home throughout the entire pandemic. Many people, particularly there's excess deaths, particularly in diabetes, due to people having poorer care. So one suggestion, quite strong suggestion, is that this is disruption to chronic diseases. No excess in cancer yet. People have always think, when are the cancer deaths going to come up? No sign of that yet. Anything else?
Could it maybe be that since people were inside for such a long period of time, people's large-scale immunity were just disrupted?
Well, we're not seeing yet. I don't think we're going to seeing that yet over the summer. Over the winter, when nobody's had flu for 2 years, it could be really serious over the winter what's going to happen. Okay, other reasons people have suggested. One is long-term effects of having COVID. Maybe some cardiac problems, from having COVID before. But the other one, quite strongly suggested, is that the massive disruption to emergency care, the delays in ambulances, which are extraordinary, the queues to get for A&E, is actually leading to increased numbers of deaths in hospital. So that's a plausible one. But there's still no answer for that. Okay, so I just want to say, from one picture, just how much you can try to think about what's driving this. Okay, so bit of maths. We know about the R number. So the R number, and this is a sort of picture that you always you've got to illustrate it. So it's a sort of image of exponential growth. If on average, and this is at the beginning of the pandemic, the golden days when the R was only 3, when it must be, with Omicron at least 8 to 10 now, I should say. With 3, so on average, someone in a completely susceptible population will be expected to infect 3 others. And that's the sort of diagram you may have seen all the time. 1 infects 3, 3 infects 3, so you get 3, 9, 27, and so on. This is a hopelessly wrong representation of what actually happens. This is grossly misleading because almost nobody infects 3 people. These are plausible distributions that are estimated in a very good paper for the actual number of people that someone infects. Now, that red distribution, the blue distribution has got a mean of 3. The red distribution has got a mean of 7. But the great majority of people don't infect anyone at all. There's a big lump on 0 and a long, long tail through super spreader events and so on. So it's one of these examples where the average is a grossly misleading summary of what actually happens. Most people with COVID don't infect anybody. These are negative binomial distributions fitted to non-China data. And this sort of idea is a running theme throughout this talk, the fact that how bad averages are. People say statisticians are obsessed with averages. No, it's the variation that's so important. So here's another example. This is a distribution estimated in a very good paper of when people die from COVID, how many years of life they've lost. Because there's always a big accusation saying, nearly everyone who dies from COVID is old, and the average age is 82. They're only losing a few, they would have died next year anyway. Well, actually, the mode of the distribution is, people who were just about to die pretty well. So the majority, the peak of the distribution is people who only lost less than a year of life, as we saw. However, the average of that distribution is 10 years because of the long, long tail that takes it out. So again, very few people actually lose 10 years. The most common thing is to only lose a few months. So the averages are so misleading. We have to know the shape of the distribution in order to actually understand what's going on. Okay, logarithms. We hear, they've been, it's the first time I think logarithms have gone public in this way over the pandemic. Because of exponential growth, if you want to turn an exponential to something linear, you take logarithms. So what happens? Just to show how nicely that can work, this is from the first wave, the number of deaths per million people in the UK, United States, and Germany. No, Italy and Germany. Notice Italy's wave came first, followed by the UK, followed by Germany. But those curves, it's difficult to see their relationship and how, in fact, how enormously similar they are on that natural scale. But if we put them on a log scale, we get a beautiful pattern of essentially parallel lines. So essentially delayed or almost exactly with the same exponent in terms of both the growth and the decline were both exponential, both almost exactly the same rate in the different countries, but just starting later and in the UK anyway, continuing a bit longer. So enormous value of logarithmic plotting in these areas where you get these exponential both growths and decline. Really valuable stuff there. Okay, I'd like to just talk about communication, because that's what I've been involved with. There's been that slide's got a bit messed up. There's been some awful government communication of maths. I think this is pretty well rock bottom. I don't know if you, in May 2020, Boris Johnson showed this slide, which, I mean, it really is so offensive, isn't it? The idea of some equation that, I mean, who knows? Anyway, it's too awful to even consider. They got an enormous criticism for that. But I don't think this is much better. I never understood that graph. What's that R equals 1 doing there? What is the vertical axis? It doesn't explain. It's really, and these are the sort of stuff they were showing, sort of pseudo-quantitative stuff that nobody really understood. Actually, this is one of my favorites. It's not my favorite, I suppose. This is still up on the website, COVID-19 Winter Plan. That was the graph showing the growth in different countries. Now, is that a linear or a logarithmic plot? They don't tell us. There's no way of telling from the labeling. It is logarithmic, I'm sure, because these are pretty well straight lines. But they didn't tell us. They just thought, it's all just done in Excel. You can reproduce this really easily. So somebody in number 10 thought, oh, well, let's draw a graph. And they did that. I mean, it's really embarrassing, it really is. And so, just a little bit of show. I was back in May 2020, they started putting statisticians on television quite a lot, and on Andrew Marr, which is the main political program. So, it gave me a chance to have a little rant about government communication of statistics, which I'm going to try to see if this works.
They're now very familiar with these daily press briefings. How well are they working, do you think?
Well, I watched yesterday's, and frankly, I found it completely embarrassing. We get told lots of big numbers, imprecise numbers of tests being done, 96,878. Well, that's not how many were done yesterday. That includes people that were posted out, tests that were posted out. We're told 31,587 people have died. No, they haven't. It's far more than that. So I think this is, actually not trustworthy communication of statistics. And it's such a missed opportunity. There's a public out there who are broadly very supportive of the measures. They're hungry for details, for facts, for genuine information. And yet they get fed this, what I call number theatre, which seems to be coordinated really much more by, a number 10 communications team, rather than genuinely trying to inform people about what's going on. I just wish that the data was being brought together and presented by people who really knew its strengths and limitations and could treat the audience with some respect. Could you understand that? Oh, good, yes. Yeah, that was my rant. It was the only rant I did in the whole pandemic. But because I get so annoyed by, there was all this data out there, and yet the politicians were using it to make political points rather than genuinely trying to inform people, which I think is really unacceptable. In general, though, I think the media have been pretty good. They've done their best. There's some fantastic data journalists out there, John Byrne-Murdoch and the FT, and others. The Spectator has done some nice stuff, Economist, they've done really good things. But some have been absolutely awful. I mean, here's a wonderful example, not wonderful at all. This is the sort of graph you get out of the dashboard showing deaths by date of death. You notice a nice smooth curve, and two waves, as we've seen before. But this is the same graph by the date at which the deaths were announced. The number, remember we used to get that every day on the news, how many new deaths have been reported. These are the numbers. Now that's really bumpy, and it's so lumpy like that because if you died in hospital on a Saturday and Sunday, they didn't put the report in until the Monday. So the values on Sunday and Monday were always very low, and then they shot up on Tuesdays and Wednesdays. And people learnt that in about a week, except some journalists who never got it. They never found out. So you had headlines like this in the Evening Standard. COVID deaths soar to 146. UK deaths soar to 262. Coronavirus deaths soar to 170. Now, you know, there's a few things in common about these. First is that this is absolutely terrible journalism. I mean, they really should get a new sub-editor to write the headlines. But the other thing is that unites all of these is that they're all on Tuesdays. So you cannot just take these numbers at face value. You have to know how they've been collected, what they mean, how they can actually be interpreted. And of course, these are 20 deaths within 28 days of a positive test. So it includes people who tested positive and then got run over by a bus 3 weeks later. Okay, here's another example of me trying to be clever. Now, this was something which I was so proud of. Right back in March 2020, I realized that if you plotted, now the black dots are the estimated mortality rate by age if you catch the virus. Now notice it's on a log scale because there's such a massive difference. This was estimated if you're 90, it's about 1 in 10 90-year-olds would die if they caught the virus. If you're 10, it's about, you know, 1 in, hang on, what's that? Almost as low as 1 in 100,000, it's about 1 in 80,000 would die. So a massive difference. What's that? An 8,000-fold difference in risk between a 10-year-old and a 90-year-old. Your risk of dying doubled for about every 7 years you're older, exponential growth. And because it's exponential, a log plot produces a nice straight line. So that was the estimates, and what I did was superimpose them on the blue and the red lines are the normal actuarial risk of dying each year at each age. It's the proportion of people who die each year. And they go along really beautifully on top. So the observation was then, without vaccines and with the first wave, if you caught COVID, your risk of dying was very similar to the risk you had of dying anyway over the next year. Which means it sort of, if you catch it, it doubles your risk of dying in the next year. It crams a year's worth of risk into 3 weeks. I thought that was really good. It was hopeless. It was disastrous. I thought it was a really good, and the BBC quite liked it. They used my plot and things like that. But look at the misunderstandings that can occur. You know, if you don't realise what's going to happen. I don't know what's happened here. Hang on, let me just try it. I want my clicker. Yeah. Katie Hopkins, before she got banned from Twitter, she was a really nasty piece of work anyway, but she had 1 million followers, and she said that this shows that corona deaths are not outpacing what is normal or usual. Because I said the risk of dying of COVID was the same as the risk of dying over the next year, she interpreted that as meaning they didn't add, you know, there wasn't any extra. I said, no, it's the same size. It's like, if I've got 2 apples, you know, got an apple here and it's the same sort of apple here, I have got 2 apples. They're not the same apple. So anyway, it was, and then the Sun headline, look at this, that Sun headline. Your risk of dying is no different this year despite coronavirus pandemic, says expert. That's me. So named underneath. I think, goodness me, you know, one's reputation just going sinking down in front of one's eyes. So what happens then, of course, you get onto the journalist and say, you've got to change this, got to change this. They changed it to that, which I don't know is that much better. So it just shows you be sort of clever and think of some nice, you know, numerical analogy comparator. It doesn't mean it won't be really misunderstood. It's very difficult to explain this stuff. What actually happened, so that's another representation of what I drew before. And that was just in March, based on a very little data. Later in October, based on 35,000 deaths, it was confirmed, that exact finding. I think it's a really good finding. Of course, it's far less now. The mortality rate now is a fraction of what it was because of both Omicron and the vaccines and prior infections. But it's still true. At the beginning, it was a year's worth of risk. Okay, so you know, we did a lot of stuff with the media, and I'd just like to challenge you to show you sort of challenges we had. You know, Anthony Masters and I wrote a column in The Observer every week for a year on COVID statistics. And then in June last year, we were confronted with this finding that it was noticed that most of the deaths that occurred from COVID were in people who had been fully vaccinated. And, there's a table, I don't, Josh, if you see it, but it just shows in each age group, of the older age group, the numbers dying in the non-vaccinated column are a lot less than the numbers dying in the fully vaccinated column. Oh my God, what's happening? Most of the COVID deaths are people who've been vaccinated. And we're saying, what's this mean? What's this mean? So we try to explain it. Okay? Who's going to try to, if you had a relation, an old uncle who said, oh, this shows that vaccines are killing people, how would you explain this?
I mean, you have to also consider the proportion of the population that is vaccinated. For example, if 80% of the people dying in a specific age range were vaccinated, but 90% of the population was vaccinated, then that 10% of the unvaccinated population would be contributing to 20% of deaths, which shows that they're still contributing more waste to their size.
Excellent. Would your Uncle George understand all of that? Is that, do you think he would? He might, yeah. Yeah, I mean, what it's really, okay, basically the idea is if you've got enough people are vaccinated, even if their risk is a lot lower, a small proportion of a very big number can still be bigger than a bigger proportion of a small number. That's another way. I've always tried to explain it that way. Nobody seems to understand it. Yeah.
How many people died of war?
Sorry?
We have more people dying outside the war today in Britain than people dying of war.
Yeah. Actually, that's one analogy. The analogy that we ended up using was seatbelts. Most people who die in car accidents are wearing seatbelts. Doesn't mean they don't work or they're useless. It means that nearly everyone's wearing a seatbelt and they're not completely perfect. So that was, we didn't make that up, but that's the one I now use, that story to try to explain. It's a base rate argument. So let's see how we might try to argue it. So here we got, why this happened, as you said, actually it was about 95% of people were vaccinated. The vaccine was very effective, reduces the death rate, by, let's say, tenfold. So the probability of dying given you're vaccinated is about 1/10 of the probability of dying given you're not vaccinated, because they're very effective. But we want to know the probability of being vaccinated given you've died. This is Bayes' theorem. This is just conditional probability, flipping round the probability. Now, unfortunately, in our column, we couldn't explain Bayes' theorem. Just can't do it. So but how I would try to do this with more time and effort would be using the idea of expected frequencies. And we wrote a whole book teaching probability, trying to teach how to communicate all these ideas, difficult, challenging ideas, using expected frequencies. So we're all used to seeing probability trees. That's the sort of thing I've drawn up. So 95% are vaccinated. In the not vaccinated, say 1% die, but in the vaccinated, 0.1% die. So that's the data I showed you. Okay, that's quite difficult to do Bayes' theorem on its own. But if we turn it into what do we mean for 100,000 people, suddenly we can, well, you probably could do it in your heads, but I would struggle, but I would do. 5,000 not vaccinated and 50 die. 95,000 vaccinated and 95 die. But that means that out of 145 deaths, the majority are in people who are vaccinated. So that's one way of taking that argument that if many people are vaccinated and it's not perfect, they can outnumber. In other words, the breakthrough deaths can outnumber the others. But this is not easy thinking. This is not an easy thing to think about. This is the only way I can actually work through it. We say, what does it mean for 100 people? What does it mean for 1,000 people? So that was quite a challenge, and it's one I try to set everybody, is to explain why most people who die with COVID. Anyway, we tried to explain this in our column, using all sorts of analogies. It's not a bad sign. This was not appreciated by some. We got this tweet saying David Spiegelhalter and Anthony Masters and the entire lying, genocidal editorial board of the management of The Guardian should be hunted down and destroyed for crimes against humanity. Thank you. I mean, what? I don't expect this sort of thing on a Sunday morning. Anyway, It was great because Anthony replied first, and he set the tone for our reply, which is to make a joke of it. So he said, "This seems a bit harsh. I thought it was a good article." And I said, "Yeah, a bit harsh, but I've seen worse referees' reports." It's, if you've been submitting academic papers, you'll know what I mean by that. So that was, he got banned from Twitter, by the way. That was considered a threat. We didn't take it very seriously. Anyway, so, but look, what happened to that data? Here is President Bolsonaro using the UK data, see the table, that's one I showed you earlier? Using that data to say that vaccines were killing people. Using UK data show that vaccines are killing people. So that's how misinformation can flow around. There's data, seems to show something, people grab it and use it. And it's not just in Brazil. Here we are, GB News in April. Government's own data should show the triple jabbed are 4 times more likely to die from COVID than unvaccinated, which is complete nonsense being propagated. Actually, I made a complaint to Ofcom about that. I haven't heard back from them. I must follow it up. Okay, so that's why, I mean, we could talk about misinformation a lot, but sort of, misinformation about numbers is absolutely vital, and it requires real, I think, effort to counter it. Okay, I'd just like to give an example of what I think is some quite good communication, which we helped with, and that's when Jonathan Van Tam, trusted figure, had to tell people about the risks of the AstraZeneca vaccine and the blood clots. Remember last year, there was a lot of worry about it. European countries were banning it for older people and things like that, and we got sent the data on the incidence of blood clots, and we had a model for the benefits of the vaccine, and they asked us, could you, this was with 48 hours notice, could you produce something to explain this to the audience? So we turned up with this graphic, which I then, which we thought was very complicated, but we thought you needed this degree of complexity. Because basically it's saying, looking at the benefits of vaccines on this side in terms of intensive care admissions avoided over 4 weeks, the harms of vaccine on this side. So it's a scale, and these are blood clots in 100,000 people. But the main thing was, the crucial thing, just I keep on emphasizing that age is overwhelmingly important thing in COVID. And so for people my age, wow, look at the benefits versus the harms, stick it in me. But if you've got 20 to 29, look at that very much fine balance. So Jonathan Van Tam, bless him, in his very trustworthy way, we thought, he put this up and thought, oh my God, he's not going to try to explain this live to an audience. He did, because he did what I was wanting others to do, which was to treat the audience with respect. He talked the whole public through that slide. And then said, so we're not recommending this vaccine for the under 30s. And everyone said, nodded, said, thank you very much. No controversy whatsoever. No fuss, no pushback. So it just shows that with a trusted communicator, and I think some quite well presented numbers, how you can avoid this misinformation. I think you can. Okay, so I'm just finishing off now. Oh, before I'm going to give you a little puzzle, if I've got time to give it. Just a final thing. I mean, I do encourage some of you, not everybody, to, when you get older, to engage with the public, with the media, to explain what you're doing, to explain what you're interested in, because we need it. We need clever people like you to be out there and getting involved. But I was on Radio 4 winter before last saying, raised voices could spread the virus, so you're going to, they'll probably ban singing, and our choir had to sing outdoors and that sort of stuff. But then I was feeling a bit mischievous. So I said, well, maybe it'd be a good idea to ban family arguments. Because now, nothing, over an unventilated room, shouting at each other over the Christmas table, the worst way, super spreader events, definitely. This was a joke. However, by an hour later, in the Daily Express, Christmas morning, families could be banned from arguing to prevent COVID spread, according to a leading British statistician. I think that was a success. I don't know. I feel a bit naughty about that, but I think it was worth it. It was definitely worth it. Okay, so I'm going to finish off with a little have I got some time for a little puzzle? Okay, I was interviewed by More or Less this morning, their radio program about probability and statistics, and they sent me a puzzle. And did you see the story last week? Now, September the 19th, which was the day of the funeral, the people in Mexico were commemorating 2 serious earthquakes in 1986 and 2017. that had caused a huge amount of damage and deaths in Mexico on September the 19th. And then there was another earthquake, and everyone on September the 19th. And everyone went, oh, must be special. Must be something special here. 3 earthquakes all on the same day. And El País International, talked to people and worked out these probabilities between 0.0007% and 0.00000024%. Those are their expert probabilities. So I was asked by more or less, okay, what's the probability of getting 3 earthquakes on the same day over 40 years? Now, let me just step you through that a little bit, and then I'm going to leave it to you, but you have to make some assumption. Chance of 3 major earthquakes, it depends on the time window. So I'm saying 40 years. I'm assuming earthquakes occur at random. And the article said every year an earthquake measuring 7 or more on the Richter scale hits Mexico City. So now we're talking about the chance, if you've got 40 earthquakes occurring at random, what's the chance of them occurring, of 3 of them occurring on the same day? Now, I sat and tried to do it in my head, roughly. And you can do it in your head, roughly. How would you go about thinking about that? Anybody want to start off? You don't have to give the answer, but how you might think about it. Because the first thing is to recognize what sort of problem it is. And I'll give you that. What sort of problem? What does this remind you of? What sort of paradox problem? Yeah? Yeah, it's a combinatoric problem. But it's often given a name. Yeah. It's the birthday problem. It's the fact that if you've got 23 people, what's the chance of 2 of them having the same birthday is more than half at random. So it's a combinatoric problem with birthdays. How would you start thinking about this one? Yeah.
All right, so I'm probably completely wrong, but I'm thinking if you take 40 and you multiply by 365 to get the amount of days, then you divide that by 3 because there are 3 earthquakes.
No, yeah, because it's the date. It's not the number of days. It doesn't have, they're not on the same day. It's just September the 19th, so that sort of repeats itself. Yeah. No, although, well, we'll see. Yeah. Yes.
Well, maybe to think about what it is and what it isn't. The chances of 3 earthquakes hitting on the same day is 1/9 of the chance of 3 not hitting on the same day. And that could potentially be easy to think about, like I thought I do with birthday problem, I think about the chance where it doesn't happen. Think now, because there's usually 2 to 3 ways for it to not be necessarily. So you have earthquakes 1 or 2 on the same day, 3 not, and so on.
Yeah, usually the best way to do this is to work out the problem of it not happening, the problem of them all happening on different days. That is the general way. That's the good way if you're trying to do it kind of exactly. I was trying to do it slightly in my head. Anybody got any ideas how you do it? Yeah.
I've got a question of clarification.
Yeah, good.
Is this like any day of the year or exactly 7?
No, exactly. The first thing is September the 19th is irrelevant. It's of any day in the year. So you've immediately got 365 opportunities. So, I mean, the general way to think about these things, I think, is to think that if I had 3 specific earthquakes and September the 19th, the chance of them all appearing on that day will be 1 over 365 cubed. But that's not what I'm interested in. That's not what I'm interested in. So I've got to work out, how many sort of possibilities there are. Yeah, sorry. Oh, dear. Oh, I can't hear. I'm sorry. I'm really sorry. I can't hear. You'll have to, if you shouted, I might. If you shouted, I might.
Is this something of sort, you have 365
Yeah.
days available for, so you have,
Well, exactly. The first thing is you've got 365 opportunities because you're not interested in that particular day. So you have to multiply that by 365 to start with. That's the first step, is to say there's 365 possible days. But you also, it's not those 3 specific earthquakes you're interested in. Yeah. Yeah. There's all these different ways of choosing those 3 earthquakes from the 40 that would occur. So you've got 40 C3, which is roughly 40 cubed over 3 factorial. I'm showing you now how I would do it in my head, trying to do it without a calculator. So you've got the 40 cubed over 3 factorial. That's roughly 40 C3, not exactly. Yeah, sorry. Yeah.
Is it the same as if it would happen on any other day?
Yeah, yeah. There's nothing special about September the 19th at all. It's just the 3 happen in any day. So if you do that, you got this basic number, if you got 40 cubed over 3, you got 365, you got 40 over 365 cubed divided by 6, which is roughly 365 divided by 9 cubed divided by 6, which is about 9 cubed, that's about half, which is about a 12th. So I did this very roughly, about 1 in 12 chance that you'd got 3 of these earthquakes on the same day over 40 years, which is nothing like 0.00000000. Now the trick then is, of course, and the other thing, that's the expected number. If you want to get the probability of there being none, you can make a Poisson approximation, and therefore the probability of at least 1 is 1 minus e to the minus that value. But that's about m. That's about that value anyway, because it's so small. So Iris did that, and in fact then, if you use Wolfram calculator, 1 in 15. 89% chance you get at least 2 on the same day, almost certain, pretty well, very certain, and a 1 in 15 chance. So this is sort of surprising, but not amazing to hear. So anyway, I had to try to explain that. You can listen on Wednesday morning, see how I get on. But it's quite tricky, try to explain that to a general audience. So that's what I was doing. Yeah, so how much time have I got? Should I shut up? 2 minutes, okay. Oh yeah, I'll get on. All right, okay, can I just finish with a bit of a performance? I don't know if you've seen this, but do you recognize that? You're the right age to recognize the Wipeout course. Okay, this is the Wipeout course in Argentina, which those of you who don't recognize it, this is an obstacle course that they used to be on television, that you went out to Argentina, 20 of you went out for a weekend, and the winner came back with £10,000. So I thought I should have a go at that. My daughter did. So I went down and did an audition as Professor Risk, and I got on it. But when I knew I'd got on it, I did my homework, did some maths, did a plot. These are the times. The point is that it's got a number of rounds, and the first qualifier, the top 12 in the qualifier, go through to the next round. And I wanted to go through to the next round. And you go on Wikipedia, you find all the qualifying times for Wipeout. And those are the qualifying times. But the most important thing is that what's the time needed to qualify? So this is the time of the 12th fastest. And it really settles down, it's a low S fit for those who are interested in the thing, really settles down in about 3 minutes. So essentially I trained to do 3 minutes. That's all I had to do, is keep going for 3 minutes. And all my training was about doing 3 minutes. And I trained seriously. Would you like to see how I got on? Okay, let's see if we make it.
Wow, this is incredible. The Total Wipeout course, it's beautiful. Look, down there. Is that 20 ordinary everyday Brits, including a railway engineer, a poker player and a penguin keeper I can see waving?
Ah, this is Professor David Spiegelhalter, OBE, and he's a professor of risk.
What this means is that if I'm going to qualify, I've just got to get below 3 minutes.
Yeah, right. Below 3 minutes is the key, and off goes the professor towards the nasty snowballs. Yes? Yes? Uh-oh.
So horrible.
He followed the y-axis when he should have followed the x. On to Granny's house now, a risky destination.
All right, Professor Spiegelhalter.
Oh! Yeah, he could still be doing this in under 3 minutes. All he has to do is clear both logs. Ow! Big ow!
The gentleman doth profess too much.
Despite that risky performance, Professor David Spiegelhalter OBE climbs to the finish in 3 minutes 17, just shy of his target. Now, taking the lead, it's Suspicious
in the
Helen,
top
followed by
12.
Saxy
Get through.
Fiona and Carolyn from Outer Space. In
fast
fourth,
they
it's
were.
Ball Crossing No Meat Marina. In seventh, Rob Boy. And scraping it through to the next round are Professor David Spiegelhalter OBE, Ali the Penguin King, and Guinea Pig Mel.
So this is the next round, next day. We've been out drinking all evening.
The 12 remaining competitors must mount the ski lift and do their utmost to remain standing. To help them, they have a podium to perch on and a bar. Finally, it's Professor David Spiegelhalter OBE.
What am I doing here? I don't stand a chance.
It's snowing!
There's boiling
Ski
hot.
pole arms have started.
Oh, and they're off!
Now, they will need to jump over both arms, which get raised up as the game goes on. Remember, the last 5 still hanging will go through to the next round.
Oh, Professor Spiegelhalter.
I don't stand a chance.
All making light work of those ski poles so far. There's Professor Spiegelhalter OBE, Rob Boy. Those poles are getting higher now. There's John. And John again. And James. Oh.
People have started falling off.
They are not letting go.
No. There's Mel. Oh no, Mel!
Oh, Mel.
There's 7
Heads
left.
down. The next 2 to 4 will be out of the competition. Marina, Suspicious Helen. Professor Spiegelhalter OBE. Ow! Ow!
I was wrong. But they stop it, they stop it.
So Professor Spiegelhalter OBE is the next victim of this first ski lift.
I was robbed.
All according to
Okay,
plan, of course.
can I
Plan
stop
was
this now?
Shows that
Right, okay. So thank you very much. It just shows you what you can do if you do stats. Thank you.